All right, so for this question, we can see we have N1, N2, X1 bar, X bar 2, sample, standard deviation. So this relates to two sample hypothesis tests, but let's look at what the questions are asking. So 59 says, determine the point estimate for the difference between the population means. So we're going to look at the cheat sheet for our two sample hypothesis testing. And we can see that the point estimate is calculated by X bar 1 minus X bar 2. I just want to point out right now, since we have sample standard deviation, we're going to be taking a look at this blue one right here. So anyways, X bar 1 minus X bar 2 is going to give us our point estimate. So X bar 1, that is 37. What I'm going to do actually right here is write 23, 26, 37, 34, 4, and 5. So we can use cell referencing. Okay. So we said X bar 1 minus X bar 2. X bar 1 is 37. X bar 2 is 34. So we're just going to subtract those. We get 3. So we say D. Determine the degrees of freedom for an interval estimation. All right, so since population standard deviation is not known, meaning we have sample standard deviation, you can see right here, we need to use the Excel template, the template for unknown variances. So I'm going to pull that up right here. And what we're going to do is we're just going to fill in these values. So our N1 is 23. So let's change this to 23. What is our X bar 1? 37. What is our sample standard deviation 1? It's 4. What is our N2? 26, 34, and 5. So when we do that, we get 46. So this is our answer, B. And now we can get rid of this. 61 is saying develop a margin of error for the confidence interval. So let's go back to this, this formula cheat sheet. You can see that we need to multiply our critical value times the standard error. So we need to get our critical value and our standard error. So how do we get our critical value? Our critical value is calculated by T of alpha divided by 2. If you guys remember this, when you're actually putting this in on Excel, we're going to do equals T dot inverse. So for the critical value, we do equals T dot inverse. We're going to do 1 minus alpha. What is our alpha? Our alpha is 0.05, 0.05 divided by 2. And our degrees of freedom, we said here, was 46. That's what we just calculated. All right, so I do that, and there is my critical value. All right, now let's get the standard error. So what's the standard error formula? That is this formula right here. The square root of standard deviation 1 squared divided by N1 plus standard deviation 2 squared divided by N2. We're going to square root that whole entire thing. Okay, so what I'm going to do right here is 4 and 5 need to be squared, right? Because standard deviation 1 and standard deviation 2 are both squared. So what I'm going to do is I'm just going to put this, I can put it right here. So standard deviation 1 squared is going to be 4 squared. And standard deviation 2 squared is going to be this value. Okay, so I said equals the square root of this value, standard deviation 1 squared, divided by our N1. So what's our N1? 23. So I'm just going to use this right here, 23, plus standard deviation 2 squared. So this divided by our N2. Our N2 is 26, so I'm just going to use this. And there's our standard error. And now we have our critical value. We have our standard error. To get our margin of error, we have to multiply the two. So I'm just going to put margin of error equals this times this. We get 2.591. So that's going to be this one.